Welcome. In a previous video, we looked at this example of making a frequency distribution for discrete numerical data. And then we made a histogram and a cumulative frequency histogram for that same data. I'm going to show in this video how to use Geogebra to graph the same set of data. Geogebra is a free online application for both computers and iPads and tablets and cell phones. It is free. It is a great resource for us to use in statistics. This is probably one of the first videos that you're seeing of it, so if you have any questions, feel free to reach out. Geogebra has a number of different tools and features, and if you get the calculator suite, you can change to a number of different calculators. We could use we will use a probability distribution calculator in the future of this class, but for right now we're going to be looking at the graphing calculator version of this. So in GeoGebra, we're going to have to type in that we want a histogram. There's a few other options we can use for graphing. We could use frequency polygon, and there will be a future video about that as well. But for this one, all we need to do is identify the list of boundaries. Now, there's a video on here that describes how to find the class boundaries for a frequency distribution. Basically, the class boundaries would be the values that are between the two different classes. So if the first class includes all people that work 0 hours, and the second class includes all people that work 1 hour per day on average, the value between these two would be 0.5. The value between 1 and 2 would be 1.5. The value between 2 and 3 would be 2.5, and so on. So we're going to need to use these class boundaries when we are graphing. And I'll show why we need to do this in a few minutes. But let me just finish filling these all in. 6.5, 6.5, 7.5, 7.5. And then lastly, in order for us to make our graph have a consistent scale, we also need to go the same distance to the left of 0 or less than 0, and the same distance to the right or beyond 8. So we need to add negative 0.5 and positive 8.5 to our class boundaries. Now, the reason why we need to use these class boundaries in the way that we have is because if we look at the graph, and this is just a picture from the previous question that we worked on. If we look at the graph here, the bar for 0 is centered around 0. So there is some value to the left and some value to the right, which gives this bar a width of 1. Similarly, if we look at the bar for 2, 2 is in the center. The value between 1 and 2 would be 1.5, and the value between 2 and 3 would be 2.5. So we need to use those class boundaries or those values between these bars in order for us to make our graph look good. So now in GeoGebra, once we've figured out the class boundaries, as we just talked about, the numbers between each of those classes, it's going to be as straightforward as just typing in the histogram function, and then we need to type in the list of boundaries with the curly brackets from our keyboard. On my keyboard, it's the buttons to the right of the letter P with a comma separating all of them and their associated frequencies. Let me move this so I can see the full table, and then I will split screen my GeoGebra so I can see both. All right, so in the input bar, I'm just going to start typing in the word histogram. If you are doing this with your cell phone, it's going to be a little bit tricky. I can show how to do this. In the f of x button, you can get the curly brackets. With the ABC button, you can type in histogram. Then we need to go back to number. We need to type in negative 0.5, comma, oops, I did that wrong. Negative 0.5, that's good, comma, positive 0.5, comma, 1.5. If you have a keyboard attached to your device, you can just use the keyboard as well. And I'm just adding a comma between each of these data values. Now, since we also have a frequency list associated here, we need to use a comma, and then we can use the curly brackets again. I'll show how to do this with the on-screen keyboard in case you're following along with a cell phone. We need to go back to this, 1, comma, 0, comma, 3, and I'm going to stop using my mouse so it doesn't make those clicks. And now we've got, now we have our histogram. And it is as simple as that. Again, we need to identify the class boundaries, so where the bar starts and where the bar ends. Where the bar starts, where the bar ends. Bar starts and bar ends. And then we can just adjust the frequency as needed. We could very easily change this from a histogram to a relative frequency histogram by changing our frequency values. Instead of using 1 and 0 and all the other frequencies, we could instead use the relative frequencies. So 0.05, comma 0, comma 0.15, comma 0.2, comma 0.15, comma 0.3. I'm not sure if you can hear the noises in my background, but my dog, Stella, just opened the door. I apologize for that. So now our graph is going to look identical to what we just had. The only difference is that our scale is now, for the vertical axis, is now not going to make much sense. In Geogebra, we can go into the settings, and we can change our Y minimum from negative 0.3 to positive, we can even just go 2.8, and that will dramatically change what this looks like. And then we can close the X, and we now have a relative frequency histogram here. And again, if we wanted to, all we need to do is change the frequency. We can now make this into a cumulative frequency by going 1, 4, 8, 11, 17, 19, 19, and 20. And again, we now have dramatically shifted our vertical scale, so let's change our vertical scale. Our minimum is still 1 or 0, and our maximum now is 20. So let's go to 22. And then we can see what the graph, the cumulative frequency histogram looks like for this data set. All right, so that's a brief introduction to Geogebra using the graphing function to create a histogram for both frequency, relative frequency, and cumulative frequency. Thanks for watching.